When you picture American infrastructure, what comes to mind? Maybe the iconic red-orange cables of the Golden Gate Bridge, or the endless rivers of cars flowing across the interstate highways. These were once the pride of a nation. The Golden Gate Bridge, completed in 1937, stood as a triumph of courage and imagination. And even earlier, the Hoover Dam stunned the world with its scale and ambition. For nearly a century, the Golden Gate didn't just connect two shores. It connected dreams. It became a monument to the era when American engineering led the world and nothing felt impossible. But today, that golden age feels distant. As the U.S. debates how to repair aging bridges and highways, something very different is happening across the Pacific. In China, a new age of engineering miracles has begun. Deep within the mountains of Guizhou, a massive structure now stands as a symbol of modern ambition, the Hejiang Canyon Bridge. Before it even opened, it was pushed to the extreme. 96 loaded trucks, weighing more than 3,700 tons, were parked across the deck, while over 400 sensors recorded every vibration and stress point. The result? A flawless victory. This wasn't just a safety test. It was a message to the world. The center of engineering excellence is shifting to the east. China is now leading a once-in-a-century infrastructure revolution. Its high-speed rail network stretches over 26,000 kilometers, linking major megacities with unmatched efficiency. In 2023 alone, China invested $2.44 trillion into infrastructure, proving that construction is the engine driving its economic momentum and global influence. And the Hejiang Canyon Bridge is perhaps the best symbol of this transformation. Set to open in 2025, the bridge spans 9,480 feet and features a main span of 4,660 feet. It cuts travel time across the canyon from 70 minutes to just 90 seconds. Beyond transportation, it includes glass walkways, bungee jumping platforms, cliffside trails, and paragliding zones, turning it into a tourist attraction on the scale of San Francisco's Golden Gate.
Built in only 3 years, this mega project demonstrates China's unmatched construction speed, its ability to conquer harsh terrain, and its emergence as the new global leader in engineering innovation. The Hejiang Canyon Bridge is not just another achievement in China's long list of engineering marvels. It is a global milestone, standing at the very peak of suspension bridge design. To understand its significance, you have to understand Guizhou. On a map, the province looks like a rumpled sheet of paper. Nearly 92.5% of it is mountains and hills, more than 1.25 million peaks, sliced apart by 8 major rivers and countless tributaries that carve the land into deep, endless gorges. Building an expressway through terrain like this is like trying to stretch a highway across the folds of the earth itself. The Hejiang Canyon, sitting between Lupanshui and Shanxinan, became one of the toughest obstacles on the Lian Expressway. Engineers had only 2 options: detour across the mountaintops, easier to align but extremely costly, or push through with more tunnels and dangerous slopes, brutally complex and risky. Instead, they chose the boldest path, to fly directly across the canyon in one giant leap at an altitude of 625 meters, 2,051 feet. At such extreme height and distance, traditional bridge types were impossible. Steel girders, arches, cable-stayed designs, none could survive the span. There was only one solution left: a super long-span suspension bridge. And so, the Hejiang Canyon Bridge was born. 2.89 kilometers, 9,480 feet long, a massive 1,420 meter, 4,660 feet main span, towering pillars rising 262 meters, 860 feet, and a deck suspended 625 meters above the canyon floor.
On paper, a suspension bridge is simple. Build 2 towers, hang 2 cables, attach the deck, done. In reality, every step is a battle against physics. Before the towers could even rise, engineers had to anchor them into rock that could take the load. They drilled 24 enormous concrete piles deep into the mountain, the deepest sinking 68 meters, the height of a 20-story building. Above ground, each 262-meter tower was assembled piece by piece, divided into more than 40 massive segments, lifted and locked together with absolute precision. Using an advanced hydraulic climbing formwork system, engineers were able to pour and lift each tower segment continuously, allowing the structure to rise at an impressive speed of nearly 0.8 meters per day. As the towers grew skyward, crews simultaneously constructed a massive gravity anchor, an enormous concrete block nearly half the size of Beijing's National Stadium. Why so massive? Because only a 400,000-ton anchor could firmly secure the two colossal main cables that would eventually support the entire bridge deck. But on the opposite side of the canyon, the terrain posed a major challenge. There was simply no room for a giant gravity anchor. Instead, engineers turned the mountain itself into the anchoring system. They excavated a deep tunnel into the rock and embedded the cables inside it, forming what's known as a tunnel anchor, a solution that required extreme precision. With both towers and anchors completed, the team moved to the next hurdle, installing the main cables. Although they appear thin from a distance, each cable is nearly 1 meter thick, wide enough for a person to walk on. But how could such massive cables be stretched across a 1,400-meter canyon? The answer: drones. A drone first carried a lightweight pilot rope across the gap. That rope then pulled a thicker one, and that thicker one pulled an even stronger one, repeated over and over until engineers built a temporary aerial walkway called a catwalk. Along this catwalk, workers installed each cable strand, each made of 91 high-strength steel wires only 5.7 millimeters thick. The first strand was the most important. It served as the reference line for all others. Using Beidou satellite positioning and total stations, engineers kept the installation error within 2 millimeters, unbelievably precise for a bridge of this size. Once all 217 strands were in place, they were compressed into a single cable, using a cable compactor. With both main cables tensioned, the project advanced to its next major task, lifting the main girder. The main girder of the Huajian Canyon Bridge weighs as much as 95 Y-20 transport aircraft and is divided into 93 giant segments. Each 200-ton segment, roughly the weight of the blade set of the world's largest wind turbine, had to be lifted and installed while battling the unpredictable and powerful canyon winds.
Thanks to an advanced cable crane system capable of millimeter-level precision, engineers were finally able to lift and connect the main girder seamlessly, officially completing the core structure of the world's highest bridge. Construction of the Huajian Canyon Bridge began on January 18, 2022. By April 2023, the first tower had already climbed to 653 feet. In January 2024, both main suspension cables were fully installed. A year later, in January 2025, the main girder was joined, and by August 2025, the bridge underwent a rigorous full-scale load test. Finally, in September 2025, this engineering giant is scheduled to open to traffic. In just a little over 3 years, engineers completed a megastructure once considered nearly impossible due to the harsh canyon terrain. During the load test, 96 heavy trucks weighing a combined 3,700 tons were positioned across the deck while more than 400 sensors monitored stress, vibration, and deformation in real time. The results confirmed that the bridge meets the highest international safety standards. Using a digital twin system, engineers also created a long-term health monitoring model that tracks the bridge's structural condition 24/7. The Huajian Canyon Bridge isn't just a bridge, it's a smart megastructure. Equipped with over 400 precision sensors, it continuously measures temperature, wind speed, stress, and vibration, transmitting everything back to a central digital twin platform. This system predicts fatigue points, extends the bridge's lifespan, and significantly reduces maintenance costs. To combat the region's notorious crosswinds, the bridge uses a newly designed aerodynamic deck, high-performance steel box girders, LiDAR-based wind monitoring, and temperature-controlled smart chips embedded within the towers to prevent stress buildup during extreme weather. Its impact goes far beyond engineering. The bridge cuts travel time over the canyon from 70 minutes to just 90 seconds, linking remote mountain towns to China's national expressway network for the first time. As part of the Lian Expressway, it connects western Guizhou to the booming Pearl River Delta, improving logistics, lowering fuel costs, and boosting regional tourism and local industries. The bridge deck even features a glass skywalk and bungee jumping platforms, earning it the nickname China's new landmark, rivaling the Golden Gate Bridge. From the Yundu service area, meaning crossing the clouds, visitors can stand 1,000 meters above sea level and witness the sea of clouds rolling beneath their feet. The Huajian Canyon Bridge is not only the pride of Guizhou, it's another milestone in China's rise as the world leader in extreme terrain bridge engineering. China now holds 8 of the world's top 10 highest bridges, with half of them located in Guizhou alone. Compared with France's Milo Viaduct, Japan's Akashi Kaikyo Bridge, or America's Golden Gate Bridge, the Huajian Canyon Bridge surpasses them in height, span, wind resistance, and construction difficulty. It sets a new global benchmark for suspension bridge design in some of the harshest conditions on Earth, providing a blueprint for future projects across the Himalayas, the Andes, and other extreme landscapes. Guizhou, once described as a land with no flat ground, has been transformed by over 30,000 bridges that now connect its people, and with the opening of the Huajian Grand Canyon Bridge, the mountains are no longer obstacles, even the clouds can be crossed. In the future history of global bridge engineering, one name will stand out above all others: the Huaijiang Grand Canyon Bridge, a miracle that seems to descend straight from the clouds. With a staggering deck height of 625 meters, it has set a new world record. Built in barely 3 years, it showcases the astonishing power and speed of China's infrastructure. And with its advanced digital intelligent management system, it marks the beginning of a new era in smart megastructures. This is far more than just a bridge. It is a signal to the world that China is leading the next chapter of human infrastructure. As the sun sinks behind the mountains of Guizhou, the Twin Towers shine like beacons of national progress. They symbolize China's relentless pursuit of innovation and stand as a reminder that no mountain is too high and no canyon too deep when determination meets engineering brilliance. Today, the world's highest bridge, the Huaijiang Grand Canyon Bridge, proves that the future of infrastructure has already arrived. Next, we turn to China's mega dams. Imagine this: colossal hydropower stations generating record-breaking electricity, tunnels carved through impossible landscapes, and bridges so tall it feels like walking on the sky. These are not just massive projects, they're built at speeds that astonish the world. Expressways, sea-crossing bridges, high-speed rail, all rising in record time. But the real question is, how did China achieve this? What secrets lie behind these engineering miracles? The answers are found in the mega projects that have reshaped our world, and at the center of them stands one of the most iconic achievements: the Three Gorges Dam, the largest hydropower project on Earth. Stretching 2.3 kilometers across the Yangtze River and towering 181 meters high, it consumed 28 million cubic meters of concrete and 460,000 tons of steel. It is not only the world's most powerful hydroelectric station, producing up to 118.8 billion kilowatt-hours per year, but also a masterpiece of inland navigation, allowing 10,000-ton cargo ships to travel from Shanghai all the way to Chongqing. Its massive 5-step ship lock and the world's largest ship lift have transformed the Yangtze into a true golden waterway. But hidden inside the dam is one of China's most astonishing achievements: the world's largest ship elevator. Standing 120 meters tall, this colossal steel structure acts like a vertical lift for ships, capable of raising vessels weighing up to 3,000 tons in just 40 minutes, a journey that once took hours. Using a counterweight system with more than 100 cables and enormous hydraulic mechanisms, it delivers unmatched precision and stability. For many engineers, this isn't just a transportation system, it's a symbol of China's willingness to redefine the limits of human engineering. From the powerful flow of the Yangtze River to the rise of this monumental structure, the Three Gorges Dam represents more than electricity. It represents vision, ambition, and humanity's ability to reshape nature itself.